Assalamualaikum warahmatullahi wabarakatuh. Greetings to all of you who are watching this video, our fellow panels. We are from group number 1. We would like to present our IDP project entitled Smart Electric Wheelchair System. We have choose team number 2, which is accessibility and mobility of people with disabilities. Before we proceed with the presentation, I would like to introduce our supervisor and others fellow members. Our IDP project has been supervised by Dr. Teo Vilset, my group leader, Mr. Chai Chi Wai, and others fellow members are Mio Arif Azwan bin Mio Azman, me myself, Muhammad Ali Zahin bin Alias, and Manoj Kiran anak lelaki Kartikeyan. Moving on to the introduction of this project, problem statement. 15% of human population are identified as disabled people according to World Health Organization, and 2/3 of them are in need of devices to overcome their mobility difficulties. One of the most famous device for disabled people in the market right now is electric wheelchair. What we found is there are several aspects lacking in the product to make it more industrial friendly, such as we can incorporate IR 4.0 and SDG into the product. We can use Internet of Things and big data to relay information to the third party and have a sufficient renewable energy sources into product. When more disabled people are working into the industrial sector, the demand of this device will increase, and it is common sense to make it more affordable. Last but not least is what we can offer to the user regarding their safety when using the product. We have 4 main objectives in this project. Number 1, to design a new contemporary generation wheelchair in accordance with IR 4.0. Second, to incorporate IoT, Internet of Things components into the wheelchair. Third, to innovate a wheelchair where minimal human effort needed to move the wheelchair. And last but not least, to infuse renewable energy sources into the wheelchair as a part of sustainable development goals.
Application. We have two decisions of this chapter. Firstly, it's design of market survey, and secondly is a survey analysis. Okay. For the design for market survey, we can conclude for 4 steps to get information about survey. Firstly, we also ask some determining question in the front part, which about are you person with disability, and if yes, the section will continue the following part. Secondly, we ask question to collect some general basic data regarding the person with disability, such as the equipment that they use the most during daily life, how much time do they use the equipment. For the third section, we ask about the problem they face regarding the equipment they use and problem during they are using the equipment. The scale is the psychometric scale where the surveys typically use question based on the scale. Lastly, the section highlight product within the opinion and requirements such as affordable and clean engineering regarding the SDG. Okay, for the survey analysis, we can summarize that the most responded want the smart electric wheelchair system which able to detect any accident occurring and send out emergency alert to the mobile application. And for more information about this survey, you can refer report to find it.
To dear panels, I'm Manoj Kiran Analaki Kartikeyan from RK08 course, and now I'll be talking about the design specification of our wheelchair. First, our wheelchair has an accident detector features followed by emergency button feature. Other than that, our wheelchair is also lightweight and it has a high weight capacity. For your information, our wheelchair uses a minimum power to move around, and it's also water and dust resistant, which extends the lifespan of the wheelchair. This wheelchair is also cheap and affordable, so those relevant people will not find hard time to buy it. Other than that, it's also easy to use and it only uses a clean energy. Next, for the specification, our wheelchair will be branded as Smart Electrical Wheelchair System, and this wheelchair is also able to alert people in case of any emergencies or even accidents. This wheelchair even has a mini backup power which is sourced from the dynamo and is used to power the IoT components. Other than that, it only weighs 8 kilos. And this wheelchair frame is made from aluminum alloy T6061T6. Next, our wheelchair comes with a quick user guide and also owner's manual. So those relevant people or users can go through in case they are facing any difficulties. Other than that, it can be used in both indoor and also outdoor. And we are targeting on people with disabled in terms of walking and also hospital and clinics, not to be forgotten health center. We are thinking of producing about 150 units initially and will be branding it as SEWS or SUS. We will be selling it at the price of 1,500 ringgit, and in terms of maintenance it will need to be done twice a year, and it's also for the battery only. In terms of warranty, we are providing a 24 months warranty for the wheelchair, dynamo and also IoTs, and a 12-month warranty for the battery. In terms of expectancy of our wheelchair, we expect our wheelchair to last for 5 years and the battery for about 3 years, the dynamo for 3 years, and lastly our IoT components for 5 years. In terms of legal requirements, we have followed the regulations set by the Ministry of Environment and Water KASA and also the SIRI Air Compliance. Next, in terms of safety and product liability, the only liability we tend to have is the IoT components where it suddenly has an unexpected failure. And for the terms of safety, we are equipping our wheelchair with the safety belts. And now getting into the manufacturing part, our wheelchair will be produced in-house and the parts used for the wheelchair is sourced locally.
Concept generation. Physical decomposition. A physical decomposition is a top-down method designed to consider the product physical existence. What we want to focus in this project is to induce the smart system into the electric chair because electric chair are available in the market. We want to induce several components that can bring out the IR 4.0 capacity and the SDG. Looking at the smart system, you can see we put components such as emergency button, impact sensor, force sensitive resistor, not MCU or Arduino Uno, ESP8266 Wi-Fi module, and buzzer. Looking at the context diagram, we have 5 main aspects included into the smart electrical wheelchair system. The most important aspect is the Internet of Things regarding the IR 4.0. We can receive impact sensor, emergency button, and FSR sensor as an input, and this information are relayed through mobile apps alert for the third party to receive using internet. Looking at the power supply, as a SDG we are mentioned earlier, we use dynamo as a secondary power sources, and these energy sources can be rechargeable. For the environment, we want to have an affordable and clean energy. And last but not least, for the maintenance, we want to have a low cost and affordable price for maintenance. For concept design, looking at the diagram here, this is our concept number 1, which we have used throughout this project as prototype. What we have found that there are 13 most important components for electric wheelchair to function. Based on these 13 components, we have produced a morphological chart to decide which material and component they are best for our product. For the design parameter and constraints, there are 6 available variables, which are ergonomic design, safety, sustainability, reliability, pocket-friendly maintenance, and imponderous targeted materials.
We have decision making, concept selection, weighted decision making, preliminary product design specification, and the selected design concept. For the decision making, we can conclude that can be quickly implemented during the real phase of the project by identifying the different options and weight the positive and negative outcome depending on each choice. Decision making is classified into the following. First is the decision under certainty. Each action result in a known outcome that will occur with a probability of 1. The secondly, the decision under uncertain. A state of nature has a assigned probability of occurrence. The third is the decision under risk. Its action can result in 2 or more outcomes, but the possibility for the state of nature are unknown. The lastly is the decision under conflict. The state of nature are replaced by course of action determined by an opponent who is trying to maximize the objective function. For the path concept selection, From the table, it is clearly shown that concept 4 has the lowest total weighted score that is equal to 1. It has the lowest plus rating and the highest minus rating among all the 4 concepts. It has the highest plus rating and lowest minus rating among all the 4 concepts by comparing both 2 and 3. Concept 2 have the highest weighted score after deducting with the minus rating than concept 3. For the weight decision matrix is a helpful tool used in comparing alternative design in line to multiple criteria of different level of importance. The criteria of rating is extracted from the result of HOQ. The first picture is the weighted decision for smart electric wheelchair, and the second is probability of weighted decision matrix for smart electric wheelchair system. And the weight decision matrix of the 4 concept, and we choose a concept 1 because the total mark will more than others. For the more details, you can refer the report for more info. For the preliminary product design specification, the table shows the updated product design specification with the description based on the change of the product specification. For more details, you can refer report to get it more information. For the selected design concept, in this project, the conceptual design 1 is selected as the final design project. Is selected with to the making complex decision using weighted decision matrix and path concept selected. It uses a finger knob joystick to control the movement. It also have 2 foot rest and hand rest. It's used for so the user the more convenient in moving and use PVC ladder because it's more variable and good in water and dust resistant. It's also used dynamo as backup power in the event of an emergency. It also include the smart system which use Arduino Uno, Wi-Fi module, impact sensor, force sensitivity resistor sensor, and the emergency button, where the impact sensor and the force sensitivity resistor sensor are used to detect for accidents like collision and the failing occurred. And for the more information, you can refer report to got it. This is a selected design concept for the asymmetry view, and the selected design concept for the overview, and we have a front view, upper view, and side view.
Anush Kiran, and now I'll be talking about chapter 6, which is the embodiment design. Getting into the key subsystem, our smart electrical wheelchair has 6 parts. First is the controller, where it consists of a joystick, followed by electric energy source, which has the rechargeable battery and also the dynamo, followed by the wheel, where it consists of tire and also the rim. Next is the braking system, and then followed by the body, where it has a frame, foot pedal, armrest, and also the seat cushion. Lastly is the smart system, where it's also the smart electrical wheelchair system's brain, where it consists of an emergency button, impact sensor, force sensitive resistor sensor, and then it has this NOT MCU LUA V3 ESP8266 module, and lastly is the buzzer. Next, getting into our product architecture, our smart electrical wheelchair has 7 types of module. First is the force sensitive resistor module, followed by the controller module, and then the motor driven module. Next, it has a power regeneration module, and then the emergency button module, and also the impact sensor module, and lastly data processing module. And this is the rough geometry layout of our smart electrical wheelchair system. The first one you can see is the brake system, and the second is the controller joystick, and then the third one is the pulley and also the timing belt system, and the fourth is the seal lead acid battery and also the high torque DC motor. Fifth and eighth has the same element, which is the footrest, and then the number 6, which is the emergency button, and also 7 and 10 they are the impact sensor. And for the number 9, which is the PVC ladder, and then for the number 11, which is the dynamo hub, and number 12, where this is the force sensitive resistor sensor is placed, and it is placed between the PVC ladder. It's inside, basically it's inside the PVC ladder. And then we also have the buzzer, buzzer, and then we also have this not MCU LUA V3 ESP8266 module over here. That's all from us. Thank you.
Good day, Doctor. My name is Chai Chiwa and my matrix number is 18110729, and I'm continue to present about the section of prototyping. Detailed design is the phase where all the details are brought together, all decisions are finalized. Next, schematic drawing for the smart system or smart electric wheelchair is shown in the figure. The purpose of this system is to detect the impact and falling of passenger on the wheelchair and send the alert notification to their family members through internet. It involves the electronic components of no MCU, FSR, no impact sensor, button module, LED and buzzer. Doctor may look for the details in the full report. All the technical drawings with dimension are done and presented in this section. Bill of material is about the quantities of components and materials that is listed to make a complete product. The table below depicts the material and cost for each part of the smart electric wheelchair system. The overall cost of the total parts is calculated based on the quantity used. Smart electric wheelchair designed by using CATIA is applied to the ANSYS software for the engineering analysis of prototype, analysis of total deformation, total equivalent stress, and safety factor for the wheelchair when human load is applied is done. The figures below shows the analysis for total equivalent stress, total deformation, and safety factor. Next, proof of concept prototype includes the following materials: design for manufacture, design for assembly, and design for environment. Doctor may look for details in the full reports. Fabrication process is the process of making something from scratch rather than assembling something. Fabrication process for the prototype started with tires, wheelchair, electronic parts, phone application, and ending with assemblation of prototype. The tires used has a diameter of 40 mm. The tires are screwed on a plain wood platform as shown in the figure. For the wheelchair part, we have decided to use the chair from our hostel to replace the real wheelchair. By using this, we can save a lot of cost for the prototyping. We tie up the chair with the plain wood platform which already screwed out with tires as shown in the figure. For the electronic parts, all electronic components used in this project are first tested to ensure they are all working fine and it is returning the desired output. The components are combined and connected to no MCU, and the coding is written to ensure that all the components runs as what we expected. Blink phone application is used to show the alert notification sent from wheelchair and passenger. The coding to communicate with Blink are added into no MCU. There are 3 different alert notifications which are shown in the figure below. Warning, impact detected. Warning, impact detected, passenger thrown off the seat. And the last one is warning, emergency button is pressed. The assembly for the final prototype can be seen in the figure below. Doctor can look for the details in the full report. For the economic analysis of product, the exact expenses and predicted profit that could be obtained in the following calculations. The overall making cost is 1,109 ringgit and 98 cents. The net sales is 1,500 ringgit. And the gross profit is 390 ringgit and 2 cents. So the gross profit margin is 35.14%. Next, the slide shown is the income statement per 150 products. The net profit is 57,301 ringgit, and the profit margin ratio is 25.47%. In this case, the net profit margin is 25.47%, means that every 1,500 ringgit contributes to the net profit of the business. Next, we proceed to the discussion and conclusion. In the discussion part, the cost of making, the material that used, and the manufacturing process are being justified based on the concept that was chosen in this session. One of the essential steps in product design is the process of choosing the suitable material. Aluminium alloy 6061 T6 material is chosen as the main material for making this wheelchair. It was chosen due to its mechanical properties such as yield strength and density for enabling lightweight and durability. This material can be recycled in the future in the form of remelting and crushed small particles for other applications. For manufacturing, one of the process involved is the harness, where the wire should not have any contact to the aluminum frame of wheelchair. While for the cost, total cost of the items, components, and parts utilized is sum out to a total of 1,109 ringgit and 98 cents only. As a result, the wheelchair will be affordable to the targeted market. To conclude the project for smart electric wheelchair system, the prototype that had been developed is able to achieve the objective set in the beginning of the project, except to innovate a wheelchair when minimum human efforts needed to move the wheelchair and fuse a renewable energy source into the wheelchair as a part of sustainable development goal due to the budget concern. The prototype can detect impact and falling of the wheelchair passenger and send out the alert notification to the caregiver or family member through IoT to the phone application. The wheelchair can send out the alert notification too by pressing the emergency button installed on the armrest of the wheelchair. The wheelchair will alert the people nearby when the situation stated above happen by trigger the LED and buzzer on the wheelchair and send out the sight and sound signals. And that's all from us. Thanks for watching the video. Thank you.